Okay, folks, we're doing the Unit 5 study guide. Here we go. Um, this test is on Thursday. You guys know that. Normal stuff, like everything's normal here. I mean, you've seen it 1,000 times, right? It's like you got your practice test, you got the video guide, which you're watching now. We got with some office hours. Tuesday will be pretty much your only time to see me, besides the Thursday donut office hours. Just really quickly, in the last assessment, I gave you a survey, I asked for song requests from you guys, and I've been listening to those, somewhat regrettably. Some of them were great, great recommendations, appreciated. I have a little playlist going through them. Some of them interesting. But something that a song to me or a piece of music for me that means a lot is this piece called Scheherazade. Let me spell it for you. Scheherazade. So if you guys didn't know, fun fact, Fun Kelly fun facts before we get started. I have played the horn ever since I was 13. And in high school, this is a piece of music that I remember very fondly, like playing like for the first time. And I don't know, it just means a lot to me. I listen to this all the time, and it's great study music. So, study music recommendation, Scheherazade. It's great. It's really good. Moving on. Okay, what do you need to know, Cold? We got the trig identity. So what do I mean by trig identities? I mean, you need to know that secant x really means 1 over cosine x, that cosecant x really means 1 over sine x, um, tan is sine x over cosine x, and cotangent is cosine x over sine x. Okay, that's what I'm talking about. You'll see. I think this comes up in the practice test a little bit, and I'll show you why you need to know these four. Um, they come from the multiple choice a little bit. Trig values, same stuff, guys. The circle, we talked about this last test, right? So you have 0, pi over 2, pi, 3 pi over 2, 2 pi, and we have our little table here. So we have like sine and cosine, and then the radians. So at 0, sine of 0, cosine is 1, right? Because this is 1 comma 0. And at pi over 2, sine is 1 and cosine is 0. And at pi, cosine 0, sine is 0, cosine is negative 1. And at 3 pi over 2, sine is negative 1, cosine 0, and so on. Right? So this is review. I'm not going to put this on the test anymore. At this point, you guys should know this, okay? So there it is. We're moving on. Some other stuff. What else we got? We got all the derivatives. This is the Fellowship of the Derivatives. I had this idea to make this handout of like all the Lord of the Rings characters like associated with different derivatives, and I was like thinking about like who's who. X the N, no doubt that's got to be Frodo, no doubt, right? I mean, key N X to the N minus one, right? We know this. This is powerful. This is all the time. You do this all the time. You live and breathe this, right? Sine is cosine X. Okay, this is a pretty common character, but like kind of a side character. It's like an Aragorn, I'd say, kind of sine x, cosine x. We got negative sine x. It's like a Legolas. Tan x, we're getting a little more obscure here. This is secant squared x. It's like a Gimli, you know, again less common. Negative cotangent squared x. Um, yeah, getting less common. Call it like Mary. Uh, no. Merry and Pippin should be a bear. My whole analogy is falling apart, and also this is completely wrong. So let's call that cosecant squared x. Jeez Louise. Secant is secant x tan x. That would be Merry. Pippin can be negative cosecant x cotangent x. Okay. I need to focus on the math clearly. Oh my god, guys. Negative cosecant squared x. Alright, let me just, okay, nx and yeah, cosine, negative sine, secant squared, negative cosecant squared, secant x, tan x, negative cosecant. Most people would start re-recording now, but, you know, I'm not going to do that. E to the x, I know this is Gandalf, because, you're going to be like, Mr. Kelly, you're going crazy. Yeah. E to the x is Gandalf, because, you know, when he dies, he returns. You know, and he, like, you know, he's Gandalf the Grey, Gandalf the White, you know, he's back. Alright, just me. A to the x is a to the x ln a. I don't really have a character for this. I'm kind of out of that now. Ln x is 1 over x, and then log is 1 over x ln a. Okay? So, you know, I guess what I would do right now is just like make sure you can just go down the line and just do all these. Like as effortlessly as me, minus the mistake, right? Just make sure you got all of them. Okay? And if you don't got them, make some flashcards and practice them. Okay? Chain rule. F of g of x. When you see this, when you see a function inside a function, derivative is f prime g of x, g prime of x. Okay? Product rule. When you have f times g, it's left d right plus right d left. We know these, right? Quotient rule. When it's f over g, we have low d high minus high d low over low squared. Okay. To do, do do, do do. Okay. And then I think like from the last test, so like feedback here, what did you guys miss the most? Um, Gotta be the quotient rule. That was the one. Quotient and chain, I think, were the two that I saw the most issues with. Quotient rule, just like the wrong order. Make sure. That's why I like. Shout out to Andre. Shout out to Andre. Low D high. You know what a revelation that was. LDH minus HDL over L squared. I kind of like that more. I mean, I don't know what the AP test thinks about that, but like I like this as at least as a mnemonic to remember it is much better. Um, you know, the AP test would want you to write it like that, but that helps you get here, right? Okay. Shout out to Andre. Um, Implicit. All right. So implicit differentiation. Uh, when you differentiate y, you have to multiply it by the derivative of y. That's like the most basic thing. When you differentiate y, multiply by dy dx. Um, you like, I mean, get dy dx alone, factor, solve. This is like the most basic explanation of implicit. If you want the detailed, I made that video, those videos about it, so you can go there, you know, watch videos, okay, if you need help. Mean value theorem. You're going to have a beautiful sentence here, right? You're going to have a beautiful sentence. So first you have the conditions. You have the conditions that it must be differentiable and continuous. Remember, differentiability implies that it is continuous. Continuous. If a function is differentiable and continuous, then we can say you find the AROC, the average rate of change. There must be a C between this interval, right? Between whatever the interval is, A to B, such that the derivative of C equals the AROC between A to C. Okay. That's like a very basic beautiful sentence. We'll get into that when the FRQ stuff, but that's the gist of it. Okay. Average value of function is 1 over b minus a. Integral a to b of some function f of x dx. That's the average value. So for average value, you don't need to do fundamental theorem of calculus. You don't really need to do anything like crazy. You just need to know this. You need to know like, okay, the formula for it, and sort of know how to use it. Okay, this is math 9 the calculator, right? Math 9, and then you would divide by the interval. Okay, that's like the very basic notes. Okay, that's pretty much it. That's all you need to know for the test. Well, kind of an asterisk on that. The function f is defined by the function f of x equals 3x minus 4 cosine 2x plus 1, and its derivative is f prime of x equals 3 plus 8 sine 2x plus 1. What are all the values of x that satisfy the conclusion of the mean value theorem applied on the interval -1, 2? Okay, so we're going to find a rock from -1 to 2. So this is in the calculator. Okay, so let's go ahead and in y1, I'm just going to graph the function. And I am going to use, there's many different ways to get values. I mean, table honestly is probably my favorite. I do like setting table set to ask so I can choose the values, and you go to table, and I'm just going to plug in -1, and I'm going to plug in a 2. And so I can say, remember that average rate of change is f of b minus f of a over b minus a. So in this case, remember this is my a, this is my b. So it's going to be 4.865 minus negative 5.161 over b minus a, which is 3. Okay, so in the calculator, let's do this. Negative 4.865 plus 5.161 divided by 3 is 3.342. Okay, then we'll go back to the graph. Now that I got my A rock, step 2 is set A rock equal to the derivative. Okay, so we're going to do that. We're going to graph the derivative. Luckily, and it gives it to us. I don't have to find it. I don't have to do anything in the calculator. I just type that in. 3 plus 8 sine 2x plus 1. Set the window pretty nicely, so make sure it's -1, okay, to 2, and then let's set this kind of nicely too from like -5 to 5, and we'll have a look. And okay, I also need to graph my average rate of change, which was 3.342. Let's graph that, and we need these two intersection points, so let's do that. Second calc intersect, and where's my cursor? I'm not seeing a cursor. Hoping it comes up pretty soon. Oh, there it is. Okay, enter, enter, enter. That one is 1.049. So you can see, all right, okay, I mean, I know it's this one, right? I know it's B, but I'll confirm that by checking B intersect. Let's move it over to the other side. Going, 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 keep going, keep going, keep going, keep going. Here we go. And then we'll go enter, enter, enter. It's negative. Yeah, you can see it matches, right? Same thing. Okay, negative 0.479. All right. So that's a mean. This is like an MVT problem. If that wasn't clear, it's MVT. The rate of change in which water is sprayed in a field of vegetables is given by R of t equals 2 root 1 plus 5 t cubed, where t is in minutes and R of t is in gallons per minute. During the time interval 0 to 4, what is the average rate of flow in gallons per minute? So no matter what, please write out the average rate of change. Okay, so remember, average rate of change, check your notes right here, 1 over b minus a, integral a to b f of x dx. So the average rate of change of this is 1 over b minus a. Remember, this is my b, this is my a. So it's 1 over 4, integral from 0 to 4. And I won't bother writing it, but it's r of t dt. Here, guys, oh my goodness, while I'm on this, do not forget, I'm going to like exclamation point, do not forget the dt. Okay, do not forget it. Do not forget it. Always include it. And here, I don't, I just need to put that rate in for my y1 now. So we got 2 root 1 plus 5x math 3 for the third power. Close it, quit it, math 9, y1, comma x, comma 0, comma 4, close it. All right, so that's right now, taking a little minute. Right now that just gave me this section, imagine. I was just going to drop it down. Right now I have, it's still 1/4 out front, but times like essentially 58.764. So now I just divide by 4. And I get 14.691. Okay, not too bad, huh? Okay, moving on. What is the average value of f? It's the same thing, guys. It's the same thing. So just know the formula, average value, 1 over 6, integral 0 to 6 of f of x. dx this time, I'm going to lose it. Okay, dx, gotta match it. Gotta match it. Okay, don't forget. I keep on seeing it. I don't want to see it anymore. Alright, so same thing. We're just going to change this. X plus 2 sine square root x was 2. Close it, quit it. I can just copy that same, copy that same equation, but it's going to be from 0 to 6, and then I'll just divide that by 6, and I'll get 3.348. So you can see, by the way, when I look at the options, see this 20.90, see it right here? It's like trying to trick you, right? So just don't forget this either. But don't forget anything. All right, that's basically just it. Don't forget the dx at the end, but also absolutely don't forget to divide. Okay, I'm gonna make a note of that. Don't forget to divide. Okay. All right, moving on. T is greater than or equal to 0. Velocity of a ship. What's the average velocity? Okay, I mean it's the same thing, guys. Okay, just be careful because it's from 1 to 15. It's not 15. It's 1 over 15 minus 1, which is 1 over 14 integral 1 to 15 v of t dt. Okay, that's it. So same thing. 1530 divided by parentheses x squared minus 24x plus 172. Close it. Back. Get that same input. It's going to be from 1 to 15. Enter. And then we're going to divide by 14. And we get 33.834. So it's got to be D. Okay, feeling good about the calculator portion? Pretty much just 2 things you need to know. Basically, math 9 is the same thing that you've been doing for a long time to find the average value. I could throw you a curveball and not say average value, just say like a quantity, But average, average, you're looking for that average value, average velocity. I think one of the keys about average value is that it's matching the same units as the original function. That's key. So it's like if you say average velocity, well, I gave you velocity. That's why you use this. Average value, key. Okay, it's easy. Just average value. Average rate, well, I gave you the rate, right? So that's when you use this. It can get confusing when it starts asking for like the average rate of change, which for this one you might get confused, but It's asking for the average rate, and I gave you the rate. It's not saying the average rate of change of the rate, it's just saying the average rate. Moving on. Let's do some no calculator. Do not use any calculator, no calculator. All right, this one, yeah, I'm still seeing mistakes on this one. This is the you give the limit definition of the derivative. This is the point limit definition. It's limit x goes to a, f of x minus f of a all over x minus a. Like this is, you'll see this all the time. There's this one and then there's the other one. There's like the x goes to h limit x approaches h, which is f of x plus h minus f of x all over h. So these are like their two like limit definitions, and both of these mean the same thing. They just mean find the derivative of f, and specifically for this one, find the derivative of f at a. So you see this, you're like, okay, I have this. I identify this is a point slope. This is like the limit definition of derivative at a point. So I'm just going to take the derivative of ln x. Remember, derivative of ln x is just 1 over x, and then I'm just going to plug in the 3. So f prime of 3 is 1 over 3, which is, yeah, a. Another thing you could do here, and I saw this on the test, is people did L'Hopital's rule for this. They plugged in the 3 and like, okay, this is 0 over 0. And then they tried to evaluate that. Weirdly, this can work. And I'm going to show you, but you guys all did it wrong. We take the derivative of the top. The derivative of the top is f prime of x, and f of 3 is a number. So really, that's minus 0. This is like, I was going to say this is L'Hopital right here. Okay. And then the bottom is 1, and then like a minus 0, right? So what you actually get is just f prime of x, right? And then the limit of that as it approaches 3, that's where you're taking the derivative of f, and you get 1 over x. You get the same answer. Basically, essentially, this brings you back here, which brings you there. Okay. If y equals ln x over x, then what's the derivative? Quotient rule. Quotient rule, quotient rule. You could do, technically, you could do a chain. No, you could do a product rule. You can't do a chain rule here. By bringing the x up, ignore that. This is quotient rule. Low x d high 1 over x minus high ln x d low 1 all over x squared. We can simplify this a little bit just to be x times 1 over x is x over x, which is 1, right? X, I'm just going to do it over here to the side, equals x over x equals 1, right? So I'm just going to write that as a 1 over here. 1 minus ln x over x squared. So my answer is D. Okay. 3. Let f be the function given by 3 sine x plus 8 e to the x was the value of f prime of 0. Take the derivative. 3. F prime of x. Always notation. Always with the notation. So important, guys. Write the notation right. Cosine x plus 8 e to the x. That easy. There's nothing else to it. Sine becomes cosine. The 8 and the 3 just stay put. Derivative of e to the x, e to the x. Nothing else to say. So now plug in a 0. F prime of 0 equals 3 cosine 0 plus 8 e to 0. Cosine 0 is 1. Gotta know it. Gotta know it. So this is just 3 times 1 plus 8 times 1, which is 11. So it's D. Okay. What is the slope of the line tangent to the graph? Okay, this is really important. Slope of the line tangent just means derivative. I mean, you guys should know this. I feel like you know this, but if that's not clear, that means derivative. So this just means find the derivative of this at 1. Kind of similar to this problem, right? Just take the derivative. So you get y prime. Low d high minus high d low over low squared. Low, x plus 1. D high. Derivative of e to the negative x is e to the negative x times the derivative of negative x, so negative 1, minus high, e to the negative x, d low, just a 1. Okay, all over low squared, x plus 1 squared. You remember this from the delta, right? Stuff like this. Plug in a 1, you're going to get 2 um, e to the negative e to the negative 1 uh, minus e to the negative 1 over x plus 1, not x plus 1, sorry, 4, because 2 squared is 4. So this is going to be negative, essentially you can think of it as like negative 2 minus 1. This is negative 3 e to the negative 1 over 4, um, which I can write as negative 3 over 4e. Okay, so that is B. So if you're feeling like rusty on this one, this was Delta 4.2. Like the harder problems Delta 4.2. But even this one, those ones were harder than this one, I would say. Just take your time. Okay. All right, we got some chain rules. Sine e to the 3x. What's the derivative? Okay, so just chain rule. So wait, I know it's chain rule because there's one x. I guess like that's I think it's always smart to identify what you're doing here. Chain rule, right? Because it's with one x. It's just functions inside of other functions. So start on the outside. Derivative sign is just cosine. So cosine e to 3x stays the same. All right, that layer is gone. Now we are at e. Derivative of e to the x is just the same thing, e to the 3x, and then we're just at the 3. It's just 3, right? So we start at sine is cosine, then we e to 3x, then we got the 3. So we look for that here. It's right here. It's D. Okay. All right. 6. This is the last of the E, ln exponential kind of problems. Um, Product rule. Lefty right plus righty left. Left, e to the 2x, d right, 3x squared, plus right, x to the third plus 1, d left, e to the 2x times 2, right? Derivative of the outside times the derivative of the inside, okay? Then plug in a 2, e to the fourth, 12, because it's 2 squared times 3 is 12, plus 9, because it's 8 plus 1, 2 to the third is 8, 8 plus 1 is 9, e to the fourth times 2. So we got, okay, so basically 12 e to the fourth plus 18 e to the fourth. Okay, so the answer to that one was D. My audio cut out for a second there. Okay, we're moving to 7. We're moving to some implicit differentiation. I'm going to get some extra paper out to make space for this. I won't be doing the different colors for the dy dx's because I assume most of you don't really, I mean, you won't be able to do that on the test, the AP test, because they won't allow those colors, right? And also, like most of you some of you liked it, some of you didn't like it, whatever. We're gonna go on. So, implicit differentiation. Let's write it out. 3x squared plus 2xy plus y squared equals 1. Differentiate straight across. 6x plus, here we got a product rule, plus 2y dy dx equals 0. Don't forget that equals 0. Okay, that's very, very common mistake, right? Make sure this that is a 0. Okay, let's have a product rule here. So remember, whenever you multiply, you have two terms. You're gonna have a product rule. We have 2x on the left there, and a y on the right. So here we go. Lefty right is gonna be 2x dy dx. Right d left is gonna be 2y. Okay. Now we'll get dy dx all on one side. These parentheses don't mean anything because it's just addition, but I think it's just a really good habit. Whenever you do a product rule, do a mini parentheses. That's my advice. We'll do minus 6x, minus 2y, minus 6x, minus 2y. And what happens is we'll get 2y dy dx plus sorry, that's an x. 2x dy dx plus 2y dy dx. Do not do what I do and write so messily that you can't tell the difference between x's and y's. Jeez Louise. Okay, I'm going to take my time here. Negative 6x. Some people write their x's like this to avoid that happening. I've seen that. Here we go. Factor it out. Dy dx 2x plus 2y equals negative 6x minus 2y. Okay, I'm going to be better about my x's and y's. Now divide, right? 2x plus 2y, 2x plus 2y. Okay, so if we go look at our options, we're done, right? This is it. If you go look at your options, our option actually isn't here, and that's because it's been simplified. Obviously on the test, like you want to write down this answer, and like if you, in case you can't figure it out, I'll give you some points, right? But you got to be able to simplify this. So we can simplify this. If you notice that every term top and bottom is divisible by 2, so we're going to take a 2 out of everything. So it's going to be, if I divide everything by 2, I'll show you what I mean by that. 3x, negative 3x minus y over 2x plus y, right? And these 2's will cancel. So now I just have negative 3x minus y over x plus y. And even from there, I can actually factor out a negative 1 out of the top of this. So I can get negative 1 times 3x plus y over x plus y. Okay, so now if I look here, I do see that term. It is b. Okay, b is what I got. If you're going to use steps, I can factor out the 2, and I factor out the negative 1. And so remember, like, something that might make this make more sense is that, like, these technically kind of have parentheses around them, right? And so when we distribute that negative 1, right, it's really being distributed to both of these terms, right? It's the same thing. Okay. All right. 8. If y equals xy plus x squared plus 1, when x equals negative 1, that is a negative 1, what is dy dx? So little thing, before we get going, I'm going to plug in the negative 1 in for x. So we're going to have y equals negative y plus 1 plus 1. So 2y equals 2, y equals 1. So my coordinate is now going to be negative 1, 1. Okay, see what I did there? All I did was take the negative 1 right here, and I plugged it in for x here and x here. Negative 1 squared is 1. Just be really, really careful with that. Write it out, nicely. It's gonna. I highly, highly recommend like you write it like this, right, with parentheses around it. I'm gonna go crazy and just like rewrite what I wrote above in case that wasn't clear. Basically like that. That's what's going on. Plugging it in, simplifying, get your coordinate. Now I know my coordinate. This is what I'm going to plug into the derivative, but I still have to get the derivative. So again, second sheet of paper. Let's do it. Coordinates negative 1, 1. We just put that to the side. And let's rewrite this. Y equals xy plus x squared plus 1. Differentiate. Dy dx equals x dy dx plus y plus 2x. I'm going to move that minus x dy dx over. So I'm going to get dy dx minus x dy dx equals x. Let me just show better work, guys. I'm being a little lazy here. I'm going to be a bit better. Y plus 2x. Then I'm going to factor the dy dx out. Dy dx, parentheses 1 minus x. Don't forget the 1 there, equals y plus 2x. So again, that's because we have 2 terms here, right? If you have 2 terms here, you need to make sure you have 2 terms here. So again, that is that, and that is that. Okay. Then, so my final answer, 1 minus x over 1 minus x. This is my answer because it's cancel. Okay. So now I plug in my coordinates. Remember x, don't lose it here, right? You got this far, let's get it right. X equals -1, y equals 1. So it's going to be 1 plus 2 times -1 over 1 minus -1. So that's going to be a -1 over 2, right? Because 1 minus 2 is -1, and 1 minus -1 is 2. Okay, so -1/2 is my answer. It's B. Okay, moving on. More implicit differentiation. Let's just keep doing them. So this one, don't get freaked out when you see a tan, guys. I think that's the concern here. This is a little bit of a trickier problem, but like nothing you can't do. Don't freak out when you see a tan or a sine. It's the same rough rules. Derivative of this is going to be a 3. Derivative of tan is secant squared y times a dy dx, right? Equals 0. Okay. Let's move. I like one piece of advice I have to you is like keep the values positive if you can. It's kind of nice. It works out nicer that way. So let's, instead of moving that 3 over, let's move the secant squared over to the right. So it's going to be plus secant squared y dy dx and plus secant squared y dy dx. So we have 3 equals secant squared y dy dx. And then from here, I can just divide by secant squared y divided by secant squared y. So this is your answer, right? 3 over secant squared y. Because there was only one dy dx term over here, I didn't have to factor it. I just could divide. So that's my answer, 3 over secant squared y. Let's have a look. Now, I don't see it, right? I don't see it from on this list. However, if you were like, you could easily rule out these two. Right, those are gone. Like that's nothing close. These two look pretty close, right? And this is where those identities come in. Remember those identities I talked about in the first part? That that secant, it's down here. Secant is 1 over cosine. Well, if secant is 1 over cosine, if you solve for cosine, cosine is what? Cosine's the opposite. Cosine is 1 over secant, right? If we solve here for cosine, I move cosine over here, and I divide by secant over here. Cosine is 1 over secant. So here, the answer is, here, I'll do it on paper. So remember, 1 over secant x is cosine x. Okay? Just like secant x is 1 over cosine x, right? Okay? So this then, by that definition, would be 3 cosine squared y. Okay? That makes sense? These are the identities. So just associate secant is with cosine and cosecant is with sine. Like weirdly, they're the other way around. Secant's with cosine and cosecant's with sine. And so again, that's just memorizing those identities that I told you, the 4 identities at the beginning. Sometimes it'll be written like cosine over sine, and like, oh, it'll say cotangent is the answer, not cosine over sine, right? So you have to know, okay, cosine over sine, that's cotangent. Some very similar thing. Or 1 over sine will be written as cosecant, right? Let me add these here just so like to be even more clear. 1 over secant x is cosine x, and 1 over sine x is cosecant x, right? Remember, like these two are essentially the same thing. They're just flipped in position. Okay. All right. moving on. But like I said, like just write the answer down that you get, right? You're gonna get the majority, for sure, the majority of the points, right? If you wrote this down, you know, you're getting 3 out of the 4 points, 3 out of 3/4 of the 1 point, right? If you wrote this down, but you didn't get the last stage of simplification. Okay, so here we go. That was 3 cosine squared. Okay, moving on. If e to the x minus y equals xy to the third plus e squared minus 18, what's dy dx at 2, 2? Kind of similar, right? Where it's just more implicit differentiation, different kinds of questions. They're a little bit more funky than the delta, right? They're a little more weird, right? But there's nothing you can't do. Let's write it out. E to the x minus y equals xy to the third plus e squared minus 18. Just gotta be careful. E to the x is e to the x. That's minus dy dx. This is a little product rule right here I'll do. And then, be careful here, guys. What's e squared? Well, e is a number, right? This is a number. This is also a number. So they go to 0, right? They are zeros. Make sure that's clear. If it's a number, don't get fooled. Don't get fooled here. That is not 2e, right? E is not a variable. E is a number. Okay, make sure that's clear. The product rule there is going to be lefty right, so it's x 3y squared dy dx plus y cubed. All right. Let's move things around. So when I move things around, I'm going to e to the x minus y to the third equals dy dx plus x3 y squared dy dx. I kind of skipped the work there. Dy dx 1 plus x3 y squared. At this point, I should move that 3 out front, but it's okay. Last step, e to the x minus y to the third, and then we're just going to divide both sides by 1 plus, I'll write it properly, 3xy squared. There's not, you're not going to get points taken off for that. It's just like the done thing that you always put the coefficient out front rather than in the middle of it like that. Okay, that cancels. So then this is what I got. And it tells me the coordinate. I don't have to find anything. It says, what is it, 2, 2? So let's plug in a 2. So x equals 2, y equals 2. So we got e squared minus 8 over both 2, so it's 4 times 2, 8 times 3, 24, 25. E squared minus 8 over 25. Do I have that? I do. That's C. Okay, that's it. 11. What is the second derivative of x squared minus y squared equals 25? I can guarantee you right now, guys. I can guarantee you, if you're listening to this, I will 100% be giving you a second derivative on the test. Whether it's in the FRQ or the MCQ, it will be on the test. 100%. You need to know how to do that. Okay? And if you know how to take the second derivative, you have mastered implicit differentiation. You understand implicit differentiation perfectly. So the steps to finding the second derivative, I will work out for you. You can watch my video about it that I did earlier, but let's do it from scratch. X squared plus y squared equals 25. Derive. 2x plus 2y dy dx equals 0. Get dy dx alone, so it's going to be minus 2x minus 2x 2y dy dx equals negative 2x, divide by 2y, divide by 2y. So dy dx equals, these 2's will cancel because it's the common factor, negative x over y. Okay. We found the first derivative. We have to find the second derivative. So to take the second derivative, we have to use quotient rule here. You could also, no. There's no other option really. We're gonna do quotient rule. So low y d high -1 minus high negative x d low dy dx over low squared. Boom. This is the second derivative. Notation. Don't be lazy like me. Always put the notation. Okay. All right. So that was my first derivative. First, second, with quotient rule, right? If it asks you to put it without, like, not at a point, what you do is just replace dy dx with this. So you take this value right here and you just replace that dy dx with negative x over y, and that would be like technically your final answer. But since it said, does that make sense? So you would just rewrite that. Should I just do it? Let me do it. So if it said find the second derivative, usually what it'll say is like find the second derivative in terms of x and y. And so the answer to that would just be, I'm going to simplify here a little bit, negative y plus, this is going to be weird. Basically, you're subbing that in. It's kind of like plus x times negative x over y squared. Right? That would kind of be the answer, but it wants it with the at a set of coordinates. What does it say? It said at 4, 3. So usually I would do that at this point. I wouldn't necessarily write it. You could do it like that, and then you could just plug a 4 and a 3 into that. That's one option. Or you can do it from this position. I would say like I kind of prefer this position. So plug a 4, x equals 4, y equals 3. I actually think it's a really good habit just to write that so you don't mess that up, because I see you guys kind of falling at that sometimes. So that means that this is negative 4 thirds, right? So dy dx is negative 4 thirds. You see that? This is dy dx at 4, 3 is negative 4 thirds. So that is going to replace that. So then y and x just get replaced with 3 and 4 respectively. So y is 3, so it's going to be 3 times negative 1 minus negative 4 times negative 4 thirds. That is where I'm subbing in negative 4 thirds into dy dx all over 9, because 3 squared is 9. All right, let's clean this up a bit here. So we got a 3, let's see here. We got 3 minus 16 thirds over 9. Let's see what is the form of my answer. It's in a fraction form. Okay, I'll simplify this. So from here, what would you do to simplify this? Well, you got to combine the 3 and the 16 thirds. That can be written as 9 thirds minus 16 thirds. 9 minus 16 is 7. So that's 7 thirds over 9. Okay. 7 thirds divided by 9 is the same thing as, so okay, whenever you have dividing complex fractions is like something really, really useful to know. So really that is a 7 thirds divided by 9 over 1. And what you do when you have complex fractions, you take the top one and you multiply it by the reciprocal of the bottom. This is the same thing as 7 thirds times 1 over 9, which is 7 over 27. Okay, is that on there? It is, yay. Let's see. Okay, good. All right, moving on. So again, on the test, if you got to this, right, you're going to want to put that answer down if you are having trouble simplifying it. But if not, just take your time, combine the fractions, divide the fractions, and you'll get there. You'll get most 3/4 of the point for writing that answer, but you'll get the full points for getting the right simplified version. Okay, and obviously I could eliminate uh like 3 of those just by the answer that I got right. Um, oh guys, why do I keep making mistakes? Oh, please, Louise. This is negative. This is negative. This is negative. Oh dear. I'm sorry. That's B. That's B. That's B. Okay. I jumped the gun on that. 9 minus 16 is -7. -7 over 3 divided by divided by 9 over 1 multiply -7 over 27. Okay, don't make my mistake. Avoid my mistakes. Okay, take your time. Take your time. Take your time. I'm saying that to myself right now. Okay, here we go. I deserve punishment for that. That is not good. Okay. Sine xy equals x. Here we go. Sine xy equals x. If, by the way, you're watching this video right now and you discover a mistake that I didn't catch, all right, you get some sort of bonus point for that. You get some sort of point. So if I make a mistake, I don't catch it in the video, you can earn some bonus points if you tell me. Okay. All right. Sine. Derivative of sine is cosine. Keeps the inside the same. Xy. Multiply by the derivative of the inside. The derivative of the inside is the product rule. X dy dx plus y equals 1. Okay. This is a weird one. In that it's not actually this is not that bad. I think it looks really complicated. Basically, we have 3 terms here. You have cosine xy, x dy dx, and y, and it equals 1. I'm going to teach you a strategy that I was telling some kids about. You absolutely do not have to do this. Basically, you have 2 options right here. You have my option, which I'll explain, or you can just straight up distribute this cosine xy into both of these and make it like these really big terms, and then get dy dx alone from there. But what I'm going to do, the method I use, is I just say that, okay, well, I'm going to say that u is cosine xy. And the only reason I'm doing this is just to make it easier to write. I'm not doing this for any other reason. This has nothing to do with the math of it. It's just to make it easier to write. So instead of saying cosine xy, I'm just going to say u. Okay? So then what I'll have is xu dy dx plus yu equals 1. Follow me? Basically, all I did there was distribute this term here and here, but I called it u because I just don't want to rewrite it the whole thing. Okay. Then from there, I am going to get dy dx alone, so I'm going to minus yu here, minus yu here. So I'm going to get xu dy dx equals 1 minus yu. Then I'm going to divide both sides by xu, divide by xu. I have my answer. This is my answer. Last thing to do is just sub back in. I said that u is cosine xy, so I'm going to sub it back in. So it's going to be 1 minus y cosine xy over x cosine xy. So let's look. And I do see it right here. Okay. Take your time, guys. Take your time. Here we go. 13. What is the slope of the line tangent? All right. Another implicit. We got 2 more implicits. Okay. So I think key to this problem, guys, and I talked about this, I don't know where I talked about this, but it's very helpful to know that the derivative of root x is 1 over 2 root x. And if you don't know that, I would just memorize that. It just comes up so often. And yeah, you can get there by converting it to an exponent and then multiplying and then just moving it down. You can do that. You can do that, right? But it's just helpful because it comes up so often, guys. Root x. Just memorize this, okay? Memorize. And that will make this problem so much easier. Okay, so we have root x plus root y equals 2. Differentiate that. We're going to get, again, based on our derivative, we just run over. That's 1 over 2 root x plus 1 over 2 root y dy dx equals 0. So that means just subtract 1 over 2 root x from both sides. And we'll have 1 over 2 root y dy dx equals negative 1 over 2 root x. Divide by 1 over 2 root x. That's a y. It's a y. 1 over 2 root y. I need to chill. Divide by 1 over 2 root y. Cancel, cancel. This is what it equals, but I need it at this point, 9/4, 1/4. So remember what I said about simplifying complex fraction. This is, again, complex fraction. This is a complex fraction because you have a fraction on top of a fraction. The way that you simplify that, if you remember, it's just you multiply by the reciprocal of the denominator. So this is just equal to negative 1 over 2 root x times 2 root y over 1. So we just have negative 2 root y over 2 root x because you just multiply across, right? And so then the 2's will cancel. So then I just have negative root y over root x. Okay. And so that, now I plug in my x and y. My x was 9/4 and my y was 1/4. So it's going to be root 1/4 over root 9/4, like that. Square root of 1/4, you just square root top and bottom. It's going to be 1/2. Square root 9 is 3, square root 4 is 2, so it's negative 1/2 over 3/2. Another complex fraction. You're just going to do negative 1/2 times the reciprocal at the bottom, which is 2/3. So it's negative 2 over 6, which is negative 1/3. Okay, I'll go over that one again. So for that one, it's no different than all the other problems. I think the square roots will mess you up a little bit. Again, key to this problem is just memorize that root x is 1 over 2 root x. Root x plus root y equals 2. Derivative 1 over 2 root x plus 1 over 2 root y. Okay, you get dy dx alone. Okay, then when you get dy dx alone, you get a complex fraction. To simplify the complex fraction, you take the top fraction and you multiply it by the reciprocal of the bottom to simplify it. When you multiply fractions, you just multiply straight across, top and bottom. Then we got root y over root x, then we put it in 1/4 and 9/4. Take the square root of that, you take the square root of top and bottom independently, 1 over 2, 3 over 2, it's all negative. Then again, another complex fraction, so I did negative 1/2, that's that negative 1/2 times the reciprocal of the bottom, which is 2/3, multiply straight across, negative 2 over 6, negative 1/3, okay? 14. Which of the following which of the following is an equation of the line tangent to x squared minus 3x y equals 10 at the point 1, negative 3? Okay. Well, we know, okay, equation of the tangent line, so you know y minus y1 equals mx minus x1. And so when you plug in 1 and negative 3 into that, you're just going to get y plus 3 equals some mx minus 1. And you can see they all have that form, right? So you're just trying to find, okay, the m. To get the m, derivative, plug in the slope, we'll get the m. So let's do that. X squared minus 3xy equals 10. Let's take the root of that. It's going to be 2x minus parentheses equals 10. Equals 0 rather, because it's going to go to 0. This negative, again, I always do that. That's how I do it. I have two terms in my product rule. I have 3x on the left. I have y on the right. So the derivative is lefty right plus righty left. It's going to be 3x dy dx plus 3y. Then we're just going to distribute that negative. So that's where that parentheses comes in handy. 2x minus 3y dy dx minus 3y. 3x dy dx. What am I doing, guys? It is, as I'm recording this, it is 9:20 on a Saturday. 9 p.m. on 9:20 p.m. on a Saturday. I just need to take my time. Okay. Yep, that looks good. Equals 0. I'm going to move this over. Like I said, trying to keep things positive in general, in my opinion, is kind of the way to go. So we're going to add 3x dy dx plus 3x dy dx. 2x minus 3y equals 3x dy dx over 3x. Cancels. Got it. This is it. Now plug in the coordinates, which are 1, -3. Remember, mark it down. X equals 1, y equals -3. What am I going to get? I'm going to get 2 times 1 minus 3 times -3 over 3. So that is 2 plus 9 over 3 is 11 over 3. All right, there we go, and I see it. 11/3, E. Okay. All right, we're out of implicit. And we're into mean value theorem and average value. We're going to get those in here. My advice for implicit, by the way, if you were struggling with any of those, is just do it over and over again. Just keep practicing it, do more delta, keep doing the delta until you feel really good about it. All right, the function f is given by the function f of x equals x to the third. The application of the mean value theorem for f on 1/3, 1, 2, 3, yada yada yada. Okay. This is basically just saying apply the mean value theorem. So we need to get the AROC, right? So first we get the AROC, which is going to be f of 3 minus f of 1 over 3 minus 1. So that's 2 on the bottom. F of 3 to the third is 27, right? So 27 minus 1. 27 minus 1 is 26. 26 over 2 is 13. Okay, so I'm trying to find out whether the derivative equals 13. So I need to take the derivative, which is, in this case, 3x squared. Okay. Okay, I just read the question again. It actually doesn't want me to find c. Okay, I need to chill. The function f is given by the function f of x equals x to the third. The application of the mean value theorem of f on the interval 1 through 3 guarantees a point. There is a point on 1, 3 at which the slope of the tangent line to the graph of f is equal to which of the following. It is equal to 13. 13 is the answer. It just wants you to find the average. This problem is just asking you to find the average rate of change. It's actually not asking you to find the c. I was about to go find the c, but it's just saying that there is a point that has the slope which is equal to which of the following. So the slope is equal to the AROC, and so that is 13. So I don't need to do this. I don't need to find the c. If it said find the c, I'd find the c. So it's 13. Continuing accurately, hopefully. Here we go. The table above gives selected values for the differentiable function of f. In which of the following intervals must there be a number c such that the derivative of c is 2? Basically here, you're just like looking at these intervals and looking for an AROC of 2, if that makes sense. And sometimes basically you'll get good at this so that you'll just know, oh, that's the one. So like, for example, if you look at 0 to 4, you don't necessarily need to find the AROC of every single one. You can like eyeball it a little bit. From 0 to 4, it's going down. So do you see that it's going from 8 to 0? That's definitely not a slope of 2 because it's going down. There's no way it's 0 to 4, right? If we look at 4 to 8, okay, well, maybe it is going up. This is going the right direction. 8 to 12 also going the right direction. 12 to 16 going down. No way it's 12, right? Because, right, look at this. We're going down, then we go up, then we go up again, and then we go down. So it's like if I want a slope of 2, well, there's no way it's a negative slope. So now I'm down to these two. Now I look at them. Okay, from 4 to 8, I'm going over 4 and I'm going up 2. Right, that's not going to work. I'll show you. It's going to be 2 minus 0 over 8 minus 4, which is 2 over 4, which is 1/2. That's not going to work. Let's check. If I check 8 to 12, right, we're going up 8. We're going 2 to 10. So we're going 10 minus 2 over 12 minus 8. That is 8 over 4. That is 2. It must be C. Okay. So these are honestly kind of gimme problems, I feel. You can get the AROC for each interval, but also you can just intuitively figure out, oh, if I want a slope of 2, right, that means I need to be going up 2. The AROC needs to equal 2, right? That's the goal. The AROC needs to equal 2. Well, you eliminate these two because it's going down. There's no way the AROC could equal 2. It has to be a negative number. Those two are out. And you look at the last two, and if you do this enough, you get good enough to just say, oh, look, it's only going up 2, but it's going over 4, and as soon as it's going over 8, up 8 and over 4. So I could identify, oh, it must be 812. But you can use AROC to like confirm your answer. Okay. Okay, this one looks like, what is this? But it's actually very, very straightforward. This is just showing the mean value theorem like on a graph. We have a function, it's continuous from 0 to 6. Okay, differentiable, yes, okay, good. Meeting the conditions. They're all points in the x-axis, okay. It is asking which are the values that satisfy the mean value theorem, right? So the values that satisfy, like, what does that mean? The values that satisfy the mean value theorems just means that these are the values whose derivatives, right? These are the C's. They are the C's that equal the AROC, right? C's satisfy MVT, right? That's what we're looking for. So if we think the AROC here from 0 to x6, that's this slope right here. So essentially it's saying which points have slopes that are equal to the AROC. And if you look here, okay, look, see x1, same slope, and x5, same slope, right? Let me highlight that, right? These guys have the same slope as this. So therefore, these satisfy it, x5 and x1. So that's what I go with. C, x1 and x5 only, okay? Because they are the values where the IROC of G is equal to the AROC. Okay? 18. The mean value theorem can be applied to which of the following functions on the closed interval -5, 5. Okay, remember the conditions. You gotta know the conditions for those questions. Conditions are continuous and differentiable. Okay, so we're not continuous if there's a 0 in the denominator, right? If you have some function over 0, that is not continuous. So essentially what this is saying is, right, because of this 0, you want to look at these functions, and if any of them have a 0 in the denominator on that interval -5, 5, they're not going to work. You see what I'm saying? So if we think, for example, sine of 0, right, 0 is on the interval. You're just going to test, you can like think like, is there a 0 in the denominator from -5, 5? Yes, there is, because sine 0 is 0, right? Sine 0 is 0, so that's not going to work. Okay? So because that's going to be 1 over 0. Not going to work. Here, same thing. X equals 1 is a 0, right? This one would be x equals 0. X equals 1 is going to make that. We'll come back to that one. If we look at D, and you were to factor the bottom, you're going to get x squared over x plus 2, x minus 2, right? That means that like both -2 and 2 are going to make zeros here, which is going to make it not continuous. If we look at this one, x squared over x squared minus 36, that's x squared over x plus 6, x minus 6. But since like these solutions, right, x equals 6 and x equals -6 are outside of this interval, that means that this is okay. Because I don't care about 6 and -6, I only care about -5 to 5. My zeros in the denominator here are 6 and -6, so it's C. Okay, so for this kind of question, you just like look at them and see which ones aren't continuous at that points in that interval. Okay. If C, I'm on 19 now. If C is the number that satisfies the conclusion of the mean value theorem, yeah. Okay, so now this is actually telling us to find the C. So same thing. Okay, this time we have to find the AROC, and then we have to find the C. So AROC is going to be f of 2 minus f of 0 over 2 minus 0, which is, okay, that's 8 minus 8 minus 8, right? 8 minus 8 is 0, and f of 0 is also 0, so it's actually going to be 0 over 2, so it's just 0. So I'm just asking, this is just asking me um, when is the derivative 0, is basically what this is saying. So, okay, we take the derivative, which is f prime of x is 3x squared minus 4x, so we're going to 3x squared minus 4x, and we're going to set that equal to 0. And we're going to get, we're going to factor out an x. We're going to have x 3x minus 4 equals 0. Okay, so my solutions are x equals 0 and I'll have 3x minus 4 equals 0, which will be plus 4 plus 4. X is going to be 4/3, right? When you solve that, you get 4/3. The answer is going to be 4/3. That's my answer. Because 0 was one of my endpoints, I'm not going to count it, right? I'm not going to count 0 because it wasn't one of my endpoints. It was one of my endpoints. 4/3 is within the interval, right? But 0 is like an endpoint, so I'm not going to count the 0. I'm only going to count the 4/3. Okay. If you think about the interval, right? That's it. Got it? Okay. So I'm going to make a note of that. This is in interval 0 to 2, right? This is not in 0, 2. Okay. All right, moving on. A portion of the graph of a differential function shown above, if the value of c equals 3 satisfies the conclusion of the mean value theorem, what is over the line tangent to graph at x equals 3? Basically, what this is saying is that C satisfies the conclusion. Remember, C satisfies conclusion just means that the tangent line at C right here is the same as the average rate of change from here to here. Okay, so if I want to find the slope of this, basically saying that these slopes are equal. So I just need to get the average rate of change, and then I'll be fine. So the average rate of change is here is going to be -3 minus 5 over, right, this is my f of b, f of a. Should I write it out? It's like f of 8 minus f of -2 over 8 minus -2 is going to be -3 minus 5 over 8 minus -2, which is going to be -8 over 10, which is -4/5. So it's got to be C. It's 20 done. All right, good news, guys. 21 canceled. Cancel this. This is gone. I'm not doing this. We decided not to do fundamental theorem of calculus on this, so this would be one that you would work out by hand. So this is done. So just say no to this. We'll do this and do this later. Okay. This is also the same thing. I'm not doing this. This is done. Okay, cancel those two. Cancel 21 and 22. They're not going to be on the test. Nothing like that's going to be on the test. I'm not going to make you work out anything by hand on the test. Okay. I will go over those over expeditions. I'll go over these. Okay. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle is given by a of t, which of the following gives you the average velocity of the particle. Okay. So average velocity, this is average value, it's asking about average value, right? So if you, to get average value, the equation is 1 over b minus a integral, integral from a to b of whatever it is that you are integrating, right? Whatever you want the average value of. So this f of x is like whatever I want average value of. So I want average velocity, that's going to be v of t in there. So looking at it, these are kind of gimmies as well. It's going to be b. I'll talk about some of the other ones. What are they talking about? A is kind of odd. A is going to give you the AROC of acceleration. That's giving you the average rate of change of acceleration, which is interesting. But it's not what you want. You want the average value of velocity, essentially the average velocity, right? This one is giving you average speed. Okay. And I don't know what the other ones are. The other ones are nothing. I don't know what those are. Those are like, I don't know. They're nothing. But these are technically other things. 24. This one could be on the test. The average value of a function over negative 1, 2 is negative 4, and the average value of f over 2, 7 is 8. What's the average value of f over negative 1, 7? So basically, to get that, I know I want basically 1 over 8, because it's 7 minus negative 1 is 8, of the integral of negative 1 to 7 of the function, right? This is what I want. So I know it's 1 over 8, but I need to find out what this area is. And I can figure that out because I know the average values of the other ones, right? So what this one's saying is that it's 1 over 3 integral from negative 1 to 2 f of x dx equals negative 4. Therefore, when I multiply by 3 by both sides, this is just 12. The integral from negative 1 to 2 f of x dx just equals negative 12. Okay, so I'm like, I've got negative 1 to 2 now. I use the same logic to get 2 to 7. So I know it's what, that's 1/5, right? It's going to be 1/5, 7 minus 2. Integral 2 to 7, f of x dx equals 8. So 5 times 8. So the integral from 2 to 7 f of x dx is 40. So 40, and then basically I'm gonna this is like rules of integrals, because these are like, these match negative 1 to 2 and 2 to 7. I can add these together. 40 plus negative 12 is 28, right? Yes, 28. So I'm going to have basically 1/8 of 28, because I'm subbing that in now. I think I need to do a better job of show my work here. I did not do a good job of just explaining this one. So basically, your whole goal of this one, the answer, if you're the long and short of it, the answer to this is 28 over 8, which is 7 over 2, which is C. If that was confusing to you, I'm going to re-explain this again. If you got it, you can move on, but I'm going to re-explain this one more time. Basically, I want the average value of negative 1 to 7. That is 1 over 8, because 7 minus negative 1 is 8, integral -1 to 7 f of x dx. So I need to find this. I need to find it. I can find it by adding the integral of -1 to 2 f of x dx plus the integral from 2 to 7 f of x dx, right? And I don't know those, but I knew the average values of them. I knew that the average value of integral, so it was 1 over 3 -1 to f of x dx was -4. And I knew that the average values would be 1 over 5 2 to 7 f of x dx was 8. And so I solved these by multiplying them by those fractions over here, by 3 here and 3 here, and then a 5 here and then a 5 here. So I solved them and I got -12, right? That's -12, is that? And then that's 40. So because of that, this is really just -12 plus 40, which is 28. So then I could take that 28 and I could sub it back into this. So it's just 1/8 times 28, which is 28 over 8. And then I divided both top and bottom by 4, which is 7 over 2. And that was my answer. Okay? All right. We're on the FRQs. Okay, we're on the FRQs. One cool thing, guys, is that at this point, I have shown you 5 out of, these are the last 2. I've shown you 5 out of the 6 FRQs from the 23 exam, which is pretty crazy. You know, we're not even in February as I'm recording this, and you've already done, or you looked at, maybe not done, but you can understand roughly 5 out of 6 of the FRQs, which is awesome. So let's look at it. One thing I want to note is that I'm not going to test you on Riemann sums, but I could test you on this part, which is interpret the meaning. So don't discount A just yet. I'm going to do the whole thing. Okay, a customer at a gas station is pumping up gasoline into a gas tank. The rate of flow of gasoline is modeled by the differential function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. So we have time here, different times, right? And it says basically how fast the gas is going in at that time, right? So it's going in, you know, faster here, the fastest here, and then it's slowing down here, and then it's 0 here, right? So using correct units, interpret the meaning of the integral from 60 to 135 in the context of the problem. So what does that mean? Well, it's an integral. Remember, an integral of a rate? Let's look at that. An integral, you should know this, and it's going to be on the test. This can be on the test. Integral of a rate is a quantity, right? So if we think about that in the context of this question, the integral of f of t from 60 to 135 f of t dt represents the total number of gallons of gas pumped into the gas tank from t equals 60 seconds to t equals 135 seconds. Something that's really, really important, guys, when you're writing out the meaning. So this makes sense, right? The integral of a rate is quantity. So the integral of from 60 to 135 represents the total number of gallons pumped into the tank, gas tank, from that time, right? Total number of gallons, right? So that's the quantity aspect of it. That's pumped into, right? Pumped into because that's the question, right? They're pumping gasoline, right? That's what's going on. Nothing's going out, right? It's all going in. That's why it's into. And also really important is that you mention, okay, t equals 60 and t equals 135. Like that's really, really important. You got to mention those two. Okay. Um, then it says use a right Riemann sum with three subintervals from 60 to 90, 90 to 120, and 120 to 135 to approximate the value of 60 to. Okay, continuing on here. I'll show you the Riemann sum. It's a nice review. I'll be giving you some review on this over expeditions. If I want to find a right-handed Riemann, I think it's good to like remind you like what's actually going on here. So we have like 0, 0. We have a point here. We have a point at 60.1. We'll call it there. We have a point at 90.15. We'll call it there. 120. Back down to 0.1. 0.05 and then 0. Let's say this is kind of what the graph, the function looks like, right? So you are just multiplying. If it's a right-hand Riemann sum, you take the right-hand values. Remember, we're going from so this is 60 to this is 90. This is 120. This is 135. We're just going to take the right-hand values and multiply them by their widths. So you get something that looks like that. Okay. So you're taking the heights and multiplying by their widths. Okay, that's how you do a Riemann sum. So we'd say that this integral from 60 to 135 f of t dt is equal to, or estimated to be equal to, so it's going to be, this one is 0.15 times 30 plus 0.1 times 30 plus 0.05 times 15. And all that together would get you 8.25. Okay? So we'd say that would be the number of gallons that were pumped in from t equals 60 to t equals 135 seconds. Okay? All right, B. Must there be a value c for 60 less than c less than 120 such that the derivative of c is 0? Justify your answer. So this is a mean value theorem problem, right? So if you see it talking about a value and asking if the derivative is a certain value, most likely that's going to be MVT, mean value theorem. Sometimes it is intermediate value theorem. It's intermediate value theorem when like you're given the derivative and it asks if that derivative exists. But like it's giving us the function and then asking for the derivative of it. So I know it's mean value theorem. Does that make sense? Okay. So mean value theorem, you got to look at your conditions. So if we see it is right here, so it says differentiable, this is key, right? That's key. You have to name that. So here we're going to say, since f is differentiable, we know if it's differentiable, we know it's continuous. So you can just draw this arrow and say f is continuous on 60, 120, right? Okay. So now we'll find the average rate of change. So we're going to do f of 120 minus f of 60 over 120 minus 60, which is going to be c. If you look here, they're both 0.1. Right, 60 and 120 are both 0.1. So it's 0.1 minus 0.1 over 60 equals 0 over 60 equals 0. Therefore, by the mean value theorem. There is a C. For C's between 60 and 120, such that the derivative of C equals 0. Okay. So key parts of this, just as a review, you gotta say that it's differentiable and therefore continuous on the interval 60 to 120. You have to say that. You find the average rate of change, and since it matches, right, since this 0 matches this 0, then we can say by the mean value theorem there is a C between 60 and 120, such that the derivative of C is 0. If you didn't want to say this term, you could say between t equals 60 and t equals 120, right? You could say that. You could say like between t equals 60 and t equals 120. You could say something like that, right? But generally, I would say it just the way I did, right? If possible. Okay, so moving on. C. The rate of flow of gasolines in gallons per second can also be modeled by this. So it's the same thing. Like this is just like the same. It's the same thing. It's the rate of flow of gasoline, but but it's a function instead of the table. Okay, and it's between 0 and 150. Using the model, find the average rate of flow of the gasoline of the time interval 0 to 150. So there's 2 points on offer here. So first point is just for writing out the correct average value formula with the right points. So it's going to be 1. I know it's average value because it's saying I want the average rate of flow, right? So I'm going to say 1 over 150 minus 0, right? B minus A, integral 0 to 150 of g of t dt. Boom. That's a point right there. And then we'll do it in the calculator. So again, put in for y1. We're going to have x divided by 500, close it, cosine, parentheses x divided by 120, close it, squared, close it. And then we'll do math 9 and y1 comma x comma 0 comma 150, close it, divided by 150, nope, not to the power of, divided by 150, 0.0959, which we could round to 0.0960, right? Okay, so equals 0.096, 3 decimals. 3 decimals, okay. Good. So we'd say like pretty sentence would be the average rate of flow of gas in gallons per second from t equals 0 to t equals 150 is 0.096. Some key things here. Average value does not change the units. So see how this is gallons per second right here? The units of average value are also gallons per second. They don't change. Just important to know that. The units stay the same for average value. Using the model G defined in C to find the value of G prime 140. Okay, so in this, you can see how this is kind of a gimme point. This is just take the derivative, right? So I'm gonna, on the calculator, I'll do the setup first. So it's just gonna be, all I have to say is G prime 140, nothing else besides that. G prime 140 equals, we'll do math 8 y1 comma x comma 140, and it is negative 0.005. Okay, so what does this mean? We have to interpret the meaning of the answer. So really, really important, what time is it happening? I might even start with that. What time is it? So I might start with that. At t equals 140 seconds, right? You always have to mention the time. The rate of flow of gasoline is decreasing at a rate of 0.005 gallons per second per second. That's it. Okay. So key things here. Mentioning the time is very important. You got to say it's happening at 140 seconds. It's a derivative of a rate. So if the derivative of the rate saying that rate of change is changing by that amount. I know the rate is decreasing because it's negative. So I say the rate of flow of gas is decreasing at a rate. It's another rate because it's a derivative of 0.005 gallons per second. Okay. It's not a double negative. That's also important. We don't say negative. You don't decrease at a negative. You just decrease by a positive, right? We would say increasing if it was a positive value here. Another option you could do here is to say, instead of decreasing at a rate, right here, you could say changing at a rate of negative 0.005. If you wanted to like not get confused with the negatives, that might be easier for you. Just saying changing at a rate of negative 0.05. Okay. All right, we're going to do the implicit problem and then we're done. We're out of here. Okay. So the implicit problem, yeah, you can expect something like this on your test, like an implicit differentiation type problem. We are going to consider the curve 6xy equals 2 plus y to the third, show that the derivative is that. So this is the solution. So what this means is like, take the derivative of this and show me that it is this. That's all it's saying. So we just need to differentiate this. So we got a little product rule here. So we're gonna have, right, 6x dy dx plus 6y equals, that's just 0, 3y squared dy dx. I will move this over, minus 6x dy dx. So we will have, when it all comes down to it, we'll have minus 6x dy dx. And we're all done. It should be 6y equals 3y squared dy dx minus 6x dy dx, and then I'll get paper. I will factor it out. 6y equals dy dx, parentheses 3y squared minus 6x, divide both sides by 3y squared minus 6x, divide by 3y squared minus 6x, so 6y over 3y squared minus 6x equals dy dx. Notice that that doesn't quite match what we want, right? We want 2y over y squared minus 6x, sorry, minus 2x. So if you notice here, we got some common factors. 3 goes in everything. So we can simplify this by taking out a 3. So it's 3 times 2y over 3y squared minus 2x. So your answer is just 2y over y squared minus 2x, confirmed. Okay, so that would be getting you the 2 points. Okay. Okay, find coordinates of a point on the curve at which the line to the curve is horizontal or explained. So kind of a cool thing about these problems is that they don't want to the reason they do this, that like they say show that this is true, is because they don't want you getting the wrong derivative and then using it in the lower ones. So like if for whatever reason you can't get this to work, this is the answer. This is dy dx. We know dy dx is 2y over y squared minus 2x, right? We know that. The line is going to tangent to the curve is horizontal when this equals 0. So when this equals 0, this is true. So what you do in this situation is you set the numerator equal to 0, right? So we're going to say okay, so 2y equals 0, all right? Also, y squared minus 2x cannot equal 0, okay? That is the line tangent to the curve is horizontal. Okay, so this just means that y must equal 0. Okay, so then we're going to take that value and we're going to plug it into the original function to get my other coordinate, right? We're trying to get a coordinate right now. The goal is to get a coordinate. So you use the fact that you know that the slope must be 0. So you set the numerator equals 0 to get like a value, and then you take that and you plug it into the original. So we're going to get, when you do that, you get 6x parentheses 0 equals 2 plus 0, which just 0 equals 2. And that is not true, right? This is no solution. So we can say, see it says why, explain why no curve exists. We can say, therefore, there is no point on the curve at which the tangent line is horizontal. Okay, got it? That's like all this. All right, sorry about the going over here. Find the coordinates of a point on the curve where the line tangent to the curve is vertical. Okay, so there's two options. It's horizontal, right? It's flat. That means that the numerator must be 0, right? And then we've got vertical, which is going straight up, which means that the denominator must be 0. So same rules apply. It's very similar but the opposite. So it's just saying that y squared, the denominator y squared must 2x must equal 0 and 2y cannot equal 0. So here it's a little bit different. Because in the delta problems where you did this, they gave you a point. If you remember, they said, oh, and x equals 3. So if you did that, then you would get this to get your y, and then that gets you your point. But in this case, it doesn't give you any point. So what you have to do is solve for x. So if you see this, you get y squared equals 2x. So x equals y squared over 2. What you're going to do is you're going to take this value, this x equals y squared over 2, You're going to substitute that in to the original equation. So let me write that out. Original equation was, move this up a little bit, 6xy equals 2 plus y cubed, and I know that x is y squared over 2, so it's going to be 6y squared over 2y equals 2 plus y to the third. So this is 3y cubed equals 2 plus y cubed minus y cubed minus y cubed. 2y cubed equals 2, and then divide by 2, divide by 2, y cubed equals 1, and then the cube root, right, of that is just 1. Y equals 1, right? That's the long and short of it. Y equals 1. Okay, then you can take the fact that you know that y equals 1, and you can plug it back in to the formula. So we can say, back to this formula. Now that I know y equals 1, it's going to be 6x1 equals 2 plus 1 cubed, which is 1. So it's going to be 6x equals 3. So divide by 6, x equals 1/2. So therefore, answer, the tangent line to the curve is vertical at 1/2 1. Okay, that's it. So just to walk through it again, you have two kinds of lines. You have horizontal and vertical. You can also have a slope of specific value, but for horizontal, you set the numerator equal to 0 and solve. If it's vertical, you set the denominator equal to 0 and then you solve. And once you solve it, whatever, in this case, once you set it equal to 0, if you don't have another point to go in, you find the value of one of the variables, and you plug that into the original, and you solve that for that value. And then once you have that, you go back to the equation, plug that value in, it gets you to the point. I will be going over this on Tuesday.